fundamental units.
Okay, so welcome to today's class, everyone. And as usual, we are going to continue with units and measurements. On Tuesday, we met to discuss the principles, the theory part of topic one, which is units and measurements. We discussed quite a number of things. The only thing remaining that I want us to discuss is dimensional analysis, and we're going to do that next week. But we can answer these questions based on the things that we already discussed on Tuesday. Everything that is in this particular question paper, we already did it on Tuesday. So we are going to start from there with the first question, reading for each of the following, list five. For each of the following, list five, which means on A, B, C, and D, we should list five of each. So the first thing we're going to do is list five base quantities for A. A is saying we should list five base quantities, which means we're supposed to list those primary or fundamental physical quantities that we discussed on Tuesday. And we said one of them or some of them that we can talk about. There are seven in total, but they're only looking for five. So we'll mention length, mass, time, electric current, but also temperature. These are five uh, base quantities or fundamental physical quantities. These are five fundamental physical quantities. Our question B is saying fundamental units. Fundamental units, which means the units of measurements that are used to measure for quantifying the base physical quantities. So you can just talk about the units of measurements that we use to measure these same physical quantities that we've written in question A. So what's the unit of measurement for length? Let's mention them. What's the unit of measurement for length?
Meters.
Okay, we have the meter represented by the small letter m. What about mass?
Kilogram.
Kilogram, also represented by kg, small letter k and small letter g. Time, I'm sure this one, it's automatic. The second, represented by a small letter s. What about electric current?
Ampere.
Okay,
Yes, sir.
represented by the capital letter A. Then what about for temperature?
Kelvin.
Kelvin, represented by capital letter K. So you should be careful with the symbols for these units of measurement. That's why on Tuesday I was showing you those lists. It contains symbols and all those things, because if you see, you might make a mistake. You see small letter m, then you think it means something else. Whilst when you see small letter m, it should represent what? It should represent mass. If you see capital letter M, it's something else. Even kilogram, you can see it's represented by a small letter k and a small letter g. So don't confuse the symbols of these physical quantities. It's one of the very important things you're supposed to do. We can look at question C, which is saying we should do list five derived physical quantities. Five derived physical quantities. So this one is also simple. We can talk about velocity. We can talk about acceleration.
Area.
Okay, someone has already mentioned area. I'll also put acceleration. Someone has mentioned force. What
Force,
else?
density,
Okay, density.
weight.
That one is saying weight. Okay, all of those are derived physical quantities. But since they mentioned to say we should only mention five, I think these are enough for today. Let's look at derived units now. What are the units of measurement for velocity?
Meter per second.
Okay, meter per second. That's for velocity. What about area?
Square meter.
Square meter.
Square meter. Acceleration. It's meter per second squared. What about force? The force, we use Newton. This is,
Newtons.
yes, so for the force, we use Newton, which is represented by capital letter N. Density, okay, we use kg per cubic meters. Kg per cubic meter is what is used as a unit of measurement for density. So there are a lot. When you talk about derived physical quantities, you can mention etc. and etc. There are a lot. Even the units of measurement, you can talk about them. There are a lot. But since the question is only asking us to mention 5 and we want to stick to time, we can list those as completing what question 1 is looking for. List 5 of each of the following. We've listed 5 basic base quantities, fundamental units, derived quantities, but also derived units, meaning we can go to the next question, which is saying which physical quantity could have units n s squared meter to the power minus 1, which is ns squared per meter, ns squared per meter. And we are from mentioning to say when you see a capital N, that means this is representing what? This is representing a Newton. Now, what are we going to do in order for us to solve this question? We're supposed to bring in the physics knowledge now, because we are not going to guess which physical quantity uses this unit of measurement. So they've included unit here. So what are we going to do first? Let's convert this derived unit of measurement into its base unit of measurement. Let's convert the Newton into its base unit of measurement. So if I was alone, I was just going to bring it out to say, okay, since they're talking about the Newton is equal to kg meter per second squared, like this. This is what Newton represents. But for you guys at your level, some of you would get confused to say, okay, where is it coming from? We know to say Newton is used to measure what? Is used to measure force. And force is equal to what? How do we calculate force? Force is equal to mass multiplied by acceleration. So mass has what unit of measurement? Mass has a kilogram as a unit of measurement. Multiplied by, what is the unit of measurement for acceleration? It is meter per second squared, like this. So we are combining these two to get this as the basic form of the derived unit of measurement, which is the Newton. So when you see Newton, it's the same as you have kg meter per second squared. That is what a Newton actually represents. So we are going to plug in this guy into this same equation that they've given us, or unit of measurement that they've given us. They've given us to say n s to the power 2 m to the power minus 1, which means m is a denominator there. So we'll replace n there with kg meter per second squared. So we're going to have kg meter per second squared, like that, being multiplied to what? Being multiplied to second squared, being multiplied to what? Being multiplied to meter to the power minus 1, like this. Okay, so now we can simplify this unit of measurement that we've been given here. We know to say if it has a power of negative, that means it is a denominator. So let's cancel out some things that are common. We have s here to the power minus 2, which means we have s squared as a denominator. Also, we also have s to the power 2, which means we have this as a numerator and this as a denominator, which means s squared and s to the power minus 2 can cancel out. They've disappeared from our equation. What else? We can see to say we have m here, and we also have the meter here. The meter here is a denominator because it is carrying a power of minus 1, whilst this one is a numerator because it is carrying a power of 1, which means these two guys can also cancel out. So the m to the power minus 1 is going to cancel out with this m that we have here. And as a simplified version of this unit of measurement, we're going to remain with what? We're going to remain with kg. Kg is the only thing that has remained from this unit of measurement that we've been given here at the top. The Newton s, the Newton s squared m to the power minus 1. We are only remaining with kg, and kg is the unit of measurement for what?
Mass.
Okay, so which means the correct answer is the mass. Unless anyone has a question. Unless anyone has a question.
Maybe you can just repeat the explanation on how you were canceling the powers and other stuff.
All right, so I was explaining to say, so let's begin from here. I was explaining to say Newton is the same as kg meter per second squared. So what are you going to notice here? Since we said if a number has a power which has a negative sign, maybe -2 or s to the power -2, like this, that means it's the same as 1 over s squared. That's why we explained to say you have to recall your basic rules of indices. That's what it means. When there's a negative power, that means it's a denominator like this. So it's the same when it comes to your units of measurement. So we have kg, meter, second squared like that, which means this is the same as kg multiplied by meter over second squared like this. Multiplied by what? Multiplied by this second squared that we have here. So we have a second squared here multiplied by what? Multiplied by this m to the power minus 1. What is this m to the power minus 1? It's the same as 1 over m like this. So what are we going to do to multiply these three guys? We're going to multiply the numerators over the multiplication, also the product of the denominator. So from here, that's why I was saying this s to the power 2 is going to cancel out with that s to the power 2. This m to the power 1 is going to cancel out with that m. What are we going to remain with? We're only remaining with kg and 1. So if I multiply kg and 1, I'm going to remain with kg here, which is the unit of measurement for our mass that we found there. I hope that is clear. Okay, let's move on to the next question. Question 3, which is saying an aircraft flies from London to Sydney in a time of 21 hours, 40 minutes. The distance traveled is 17,000 kilometers. What is the average speed of the aircraft in meters per second? What is the average speed of the aircraft in meters per second? Okay, so first things first, we're supposed to bring out the formula for average speed. Formula for average speed, which is equal to what? Which is equal to total distance.
Over time.
Total distance over time taken. This is the formula that we are going to use. But if you look at the time that we have, the time is not in its significant, or rather in its SI units. It's not in its SI units. It has been given in 21 hours, 40 minutes. Whilst we know to say the SI unit for time is the second. That's why even at the end here, they've specified to say leave your answer in meters per second, which means we are going to convert this value of time that we've been given into what? Into seconds. How are we going to do that? Remember, we said 1 hour is equal to what? Is equal to 3600 seconds, like this. Whilst 1 minute is equal to what? It's equal to 60 seconds. So what are we going to do? Let's convert our 21 hours, 40 minutes into seconds. First, we have 21 hours. So we can say 21 hours multiplied by 3600. This is going to give us how many seconds? Whilst at the same time, we have 40 minutes multiplied by 60 seconds. This is going to be 21 multiplied by 3600. What answer are we getting? Yeah, so
78.
sorry,
I think about 78,000 there, something like that.
75,600 seconds. Whilst 40 multiplied by 60, this is going to give us 2,400 seconds. So you add those two. What's the final answer here? You're going to get 78,000 seconds, like this. So if this is the total time taken, let's now convert our distance into meters. It has also been given in kilometers, and you know to say 1 kilometer is equal to what? It's equal to 1,000 meters. So the 17,000 kilometers that we have there, 17,000 multiplied by 10 to the power 3, which is basically 1,000, will give us how much as our total distance? It will give us 1.7 times 10 to the power 7 meters. Okay, so these are the two values now that we're going to use to find our average speed. So we'll bring down the formula again, in this same formula, and we're going to say the total distance, which is 1.7 times 10 to the power 7 meters over 78,000, which is the same as 7.8 times 10 to the power 3 seconds. This is going to give us how much? This is going to give us how much? Oh, this is to the power 4. Yeah, this is to the power 4, not to the power 3, because it's 78,000, not 7,300. Yes. This is to the power 4 like that. Okay. What final answer do we get from here?
Yeah, I'm getting 2.179487179 times 10 to the power times 10 to the power 10.
Times 10 to the power 10. Is it to the power 10? Anyone who is getting a similar answer? That power there is not convincing me. It's too big. Anyone who has found a different answer? Okay, so I'm finding 2.18, which is basically what our friend that talked about to say 179. So we'll just round it off to 2 decimal places to 2.18 times 10 to the power 2 meters per second. Anyone else who has found an answer which is similar to this?
Yes, it's giving the same answer. That is 2.179. And if you convert it, it will be 2.18.
All right, so let's check our answers. We have A, 2.2 meters per second. B, 2.2 times 10 to the power 7 micrometers per second. C, 2.2 times 10 to the power 11 nanometers per second. And D, 2.2 times 10 to the power 6 millimeters per second. Okay, so this answer that has been given here, you've I guess you've noticed what is happening here. The question is asking us to say, find your answer in meters per second. Find your answer in meters per second. But if we check the options that we've been given here, the answer that is in meters per second is not the same as the answer that we've calculated. Have you noticed that? We only have 2.2 meters per second. So which means this statement here is confusing people. They said your answer should be in meters per second, but if you check the answers that are here, these are not in meters per second, and the only answer that is in meters per second is not correct, which means we're supposed to convert this answer further to check whether it is B, C, or D. Yes, so that is what we are going to do next. Okay, so we've gotten 2.18 times 10 to the power minus 2.2 times 10 to the power 2 meters per second. This is the answer that we've gotten in meters per second as they asked at this particular point. But let's convert it further into to check whether it is this one or that one or that one, because A automatically is not the answer. So let's convert it into micrometers per second. Let's try and convert it into micrometers, and we know to say 1 meter is equal to what? Is equal to 10 to the power 6 micrometers, like this. Or what can we say? We can say 1 micrometer is equal to 10 to the power minus 6 meters. Yeah, either way, whichever way you can think of. So can we convert this into micrometers? Anyone who knows how to convert? What did we say? We're only converting the distance. The time will maintain the second, just like that. How or what are we going to have in micrometers per second? If we convert it, we're going to say 2.18 times 10 to the power 2 meters over the second there multiplied by the conversion factor. We're trying to get rid of the meter, so the meter will be down here as 1 meter. Then we have what? We have 10 to the power 6 micrometers at the top there. This is going to give us what? This meter and that meter will cancel out. So 2.18 times 10 to the power 2 multiplied by this guy that we have here. What answer are we going to get? Yes.
2.18
2.18, yes. 2.18
times 10 to the power 8 micrometer.
times 10 to the power 80 micrometers per second. Okay, do we have an answer which looks like this on our options?
I don't think so.
Do we have an answer that looks like this?
No.
No,
Okay.
we don't have.
Okay, since we don't have, that means we are going to continue with our conversions. Let's look at C. So this is going to take a lot of time, huh? I've just noticed. So let's bring in another conversion factor. Let's try and check the remaining two, since this one is not an answer. Let's check the nanometer. Let's check the nanometer. So what's the conversion factor from a meter to a nanometer?
It's 10 power negative 9.
Okay, 1 meter is equal to 10 to the power 9 nanometers,
Right.
like this. Okay, so we're going to do the same. We're going to say our 2.18 times 10 to the power 2, like that. This is meters over the second, multiplied by, what do we have? We have 1 meter, then we have 10 to the power 9 nanometers, like that. What answer is this going to give us?
2.18 times 10 to the power 11.
Is anyone else finding this answer?
Yes. 2.18 times 10 to the power 11. Yeah.
Okay, so it's 2.18 times 10 to the power 11 nanometers per second, right?
Yes.
Okay, so if this is equal to that, then that means we've found the answer, because the figure that is in nanometers is C, and C is telling us 2.2 times 10 to the power 11. So which means they've rounded it off to one decimal place. Since this guy is greater than a 5, we'll round this one up, meaning we'll have a 2.2 times 10 to the power 11 nanometers per second. So that means the correct answer is C. Are we all in agreement?
Question, sir. A question.
Yes.
Since you're saying they're rounding it off, doesn't that mean maybe even the first one is correct?
Which first one? This one?
Oh, sorry, I made a mistake. Sorry.
Yes, I've noticed what you did, and yeah, those mistakes do happen. This is just 2.2. Here we have an exponent of 2.
Yes, I see, sir. I see now.
All right, so the correct answer is option B on the options that they've given us. But when they asked to say leave it in meters per second, the correct answer was this one, which is here. So take note of those minor changes. We can now move on to the next question, which is saying which of the following prefixes represents the smallest multiplication factor? Which of the following prefixes represents the smallest multiplication factor? Okay, so this one I don't even need to explain. It's a very, very simple question. We just get it directly from that table that I was showing you on metric prefixes. So which one is the smallest amongst these that we've been given here?
This nano is -9, micro -7, or -6. Mainly it's 3.
Okay, so we said this one is equal to what? It's equal to 10 to the power minus 3. This one is equal to 10 to the power minus 6. This one is equal to 10 to the power minus 9. What about pico?
-12.
Okay, pico is equal to 10 to the power minus 12, like that. So which one is the smallest amongst these?
Mainly 10 to the power -3.
Which one is
10 to
the
the power negative
smallest?
3.
It's people.
10 to the power negative
It's people.
12.
It's people. It's people.
Okay, so
Ano,
it's
idea.
it's the pico. Pico is the smallest, because if you say 10 to the power -3, that means you have 0.001, like this, right?
Yeah.
Oh,
If you have 10 to the power -6, that means you have 0.00001, 2, 3, 4, 5. Yes. If you have 10 to the power -9, the same. The zeros keep on increasing, because there's a negative power there. So please don't make that mistake. The smallest here is the one which has the highest negative power. Because the numbers, as you go, as they increase towards the negative side, that means your value is getting smaller, smaller and small. So the pico here is the smallest multiplication factor. So the correct answer is D. Okay, can move on to the next one, which is saying five ball bearings are arranged by the side of a ruler with 2 set squares at either ends of the ball bearings. what is the approximate radius of one of the ball bearings? What is the approximate radius of one of the ball bearings? Okay, so this is also another very, very simple question. They're asking us, what is the radius of each ball? So what are we going to do first? Anyone who has an idea?
You're going to find the average diameter for O by measuring the distance using the ruler.
Okay, so
Then you divide by 5,
and
and then you divide by 2.
all right, so
Depende tu tu.
let's take note. Those who are unmuted, please. There is a lot of background noise. Okay, so as our friend was saying, the first thing we're going to do is find the total length of the 5 balls that are here. And we're going to check our ruler. This is ruler is up to scale. And you can see to say the length is starting from this point. And what is this point? It is 0.9. So we're moving from 0.9 all the way up to 4.2. This is 4.2. 4.2. So the total length of the 5 bearings is equal to what? Is equal to 4.2 minus 0.9. And this is going to give us what? This is going to give us 3.3 centimeters. 3.3 centimeters is the total length of the 5 balls. That's the length that all the 5 balls are covering. So from here now, what are we going to do? These guys are touching each other. So the total length that we've calculated, this one, is equal to the 5 diameters of these balls. The total length of that we've calculated, the 3.3, is equal to the 5 diameters. The diameter of this one plus the diameter of this one plus the diameter of that one, or the 5. So what are we going to say? We know to say we calculate diameter using this formula, 2 multiplied by radius. So say the length, the total length, is equal to the 5 diameters. 5 diameters. Now I'm going to replace this diameter that I have here with 2r, because this is the formula that we use to calculate diameter. So I'll say my total length is equal to 5 multiplied by diameter, of which what is the formula for diameter? Diameter is equal to 2 multiplied by r. R, which is representing radius. So the total length is equal to 10 r. R is for radius. What is the total length? The total length is 3.3. So we're going to say 3.3 is equal to 10 multiplied by r. Then from here, we divide both sides by 10, even that side by 10. That means the radius of each ball is equal to what? What will be the answer?
0.33.
0.33 centimeters. And just like that, we are done with our question, I don't know what, question 5. That is all about question 5. It's very simple. There is someone who sent me this question to my inbox yesterday. I told them we are going to solve it together. I just hope they managed to attend this class. So question 6 is saying a cook wants to prepare some food by 13:05, which means by this time the food should be prepared. He uses an oven with an automatic timer that can be set to switch on and off at certain times. The food should be cooked for 2 hours, 10 minutes. At what time does he switch on the oven? Okay, so this is a very simple question. Just tell me the answer so that I may write.
11:05 or 10:05, I mean.
Okay, 10:05.
10:55, I mean, sorry.
Okay, someone is saying 10:55. Anyone else with a
10:55.
different answer? Anyone else with a different answer? Okay, so the correct answer is 10:55. Why? It's because we're only going to subtract these 2 hours, 10 minutes from the 13 hours, from the 13:05 that they've given us, such that by this time, the food should be cooked, should be ready. So we're going to say 13:05 minus what? Minus 210. I don't know how you can do it using this basic mathematics for grade 12. But if you want, you can just subtract 2 hours from 13:05. You're going to get 11:05. Then you subtract 10 minutes from there. You're going to get 10:55. Not 10:05, sorry, but 10:55. That is the final answer. That is the final answer for question 6. Okay, so we have this question which is saying convert 60 meters per second to kilometers per hour. Convert 60 meters per second to kilometers per hour. Okay, so this is one of those simple questions that I was talking about. So we're going to say 60 meters per 1 second, like that, multiplied by the conversion factor for a meter to a kilometer is equal to what? We want to get rid of the meter, so say 1 kilometer here, which gives us 1,000 meters multiplied by 1 hour, which gives us what? Which gives us 3,600 seconds, like this. From here, this second is going to cancel out with that second. Then this meter is also going to cancel out with this meter, which means to simplify this, we're remaining with what? We're remaining with 60 multiplied by 1 kilometer multiplied by 3,600 over 1,000 multiplied by 1 hour, like this. Okay, so from here, what answer are we going to get? If you say 60 multiplied by 1 kilometer multiplied by 3,600 divided by 1,000 multiplied by 1 hour, what answer are we going to get? Quickly.
Hundred and 16.
Sorry, what did you say?
216.
Okay, so this distance to kilometers per hour will be 216 kilometers per hour. 216 kilometers per hour will be this distance. 60 meters per second. Okay, anyone with a question? All right, let's look at this one, which is saying determine the SI base units of coulomb, volt, and ohm. Determine the SI base units of coulomb, volt, and the ohm. Okay, so this question is a bit talking about, or it involves you to know the dimensions that each of these contain. It's the same thing we're doing with the Newton. Those who are following, if you saw what we did with the Newton, it's the same thing we're going to do to these. We're just converting these derived units of measurement. We are expressing them in form of base units. We're expressing them in form of base units. If you remember, we said the Newton is equal to what? Is equal to kg meter per second squared, like this. This is what we said. So it's the same thing we're supposed to do here. So they're just asking us to say, determine the SI base units for coulomb, which is a derived unit, for volt, which is also a derived unit, but also ohm, which is also a derived unit. So what are we going to do? We are supposed to know the dimensions that make up the physical quantity that is measured using the coulomb. So what physical quantity is measured using the coulomb? It's the charge. You look at charges in P192 next semester a lot in electricity. So charge is the one which is measured in coulomb, and charge is expressed as what? Charge is expressed as current, which is electrical current, multiplied by time. Charge is expressed as electrical current multiplied by time. So we're supposed to remember the unit of measurement for current, but also the unit of measurement for time. So if we multiply those two, what is the unit of measurement of current? What is the unit of measurement for current?
Amps.
Okay, it's amps, ampere. So say A, it is represented by A. Someone was saying I represents current. Current has a symbol of I. The unit of measurement for current is ampere with the symbol capital A. Please take note of that. Then we have time, which is measured in what?
Seconds.
Okay, time is measured in seconds, which means charge is the same as what? Is the same as the current multiplied by second. These are the SI base units for charge. I hope we are clear there. Okay, let's look at the volt. This is also another derived unit. Volt. Volt is used to measure what? For voltage. Voltage is the one which is measured in volts. So voltage is equal to what? The dimensions for voltage. What are the dimensions for voltage? Anyone who has studied ahead, we're going to look at them next week when discussing dimensional analysis. These are very simple things. There's nothing complicated here. Sorry?
Power over current.
Power over current. Okay, so let's if we talk about power is also another derived physical quantity. So let's just use the base quantities.
What?
Or rather, let's just give a direct expression. Not necessarily base quantities, but a direct expression. The voltage, how do you calculate voltage passing through a certain point? We say it's equal to work done
Overcharge.
over the charge. We are from finding the SI base units of charge here, and work done is equal to what? Work done is equal to what?
Voltage minus.
Sorry?
Force times distance.
Very good. Work done is equal to force multiplied by distance. And this divided by charge. We've already found the SI base units for charge. So this one is going to continue. Force has SI units of Newton, which were it's this guy that we have here. We're going to plug it in. So we're just going to say kg meter second to the power minus 2 there, multiplied by distance. Distance is measured in what? In meters, divided by amp second, like that. Okay, so can you simplify this equation further to find us the final equation? That will be our final SI base units for voltage or for volt.
The second will have -3.
The second will have a -3. Okay. Okay. Anything else? Anything else? Of course, the second here as a denominator and the second there as a denominator. So the second is going to have a power -3. That is if we bring all the things to the top there. So we're going to have meter multiplied by the meter that is here, which means we're going to have square meter like that. So our final SI base units will be kg meter squared second to the power -3, as our friend has already said. Then we're also going to express this as a numerator, which is going to make it carry a power -1 like that. So this will be our final equation. If you don't want, you can write it in its basic form. There's no harm in doing so. You're just going to say kg meter squared second to the power -2. Where is it? Second to the power -2, like this, over amps per second, just like this. This is also correct. Any question? Okay, let's look at the ohm. The ohm is used to measure which physical quantity? That would be the first question. Which physical quantity do we measure using ohms?
Resistance.
Okay, we measure resistance using ohms. So the dimensional formula for resistance is equal to voltage over current. We've already looked at the SI base units for voltage or for watt. So that shouldn't be a very big deal. So we are from saying voltage is equal to what? Or I've rubbed everything here. Said it was equal to kg meter squared second to the power minus 3 amp to the power minus 1 like this, and that divided by what? Divided by the SI unit of measuring current, which is the amp. And from here, this is going to be equal to what? You can leave it like this if you want. There is no harm in doing so, but you can also write it as kg meter squared second to the power minus 3 and amp to the power minus 2, since you have two denominators of ampere, like that. That is the ohm. The SI base units for measurement of resistance is equal to kg meter squared second to the power minus 3 amp to the power minus 2. That is the SI base unit, the SI base units of these three. So we found all of them, the coulomb, the volt, but also the ohm. Okay, convert the following 300 millimeters into megameters. Convert the following 300 millimeters into megameters. That is also a very simple conversion. Converting a millimeter to a megameter. What do we do? Converting
Make a conversion factor.
Okay, so we have to come up with a conversion factor. So what is the conversion factor of millimeter to megameter? Of course, if you use the meter as a reference, you're going to notice to say millimeter is equal to what? Millimeter is equal to 10 to the power minus 3. Millimeter is equal to 10 to the power minus 3. Whilst megameter is equal to what? Megameter is equal to 10 to the power 6. This is the difference between a milli and a mega. So what direct relationship can we give between a millimeter and a megameter? What direct relationship can we give? How do we find the direct relationship? If you want, it's okay. You can first convert it into meters using this one that we've written here. Then from there, you convert it to megameters using this one. There's no problem. It's okay, because you're just using the basics. But if you don't want, you can actually, from these two that we've written here, you can derive your direct conversion factor between the millimeter and the megameter. So how are we going to do that? That's the question. How do we do that? Anyone who knows? Anyone who knows? Okay, so I feel like let's just solve it in two parts, or let's solve it in two different ways. So we'll say, let's convert first 300 millimeters to meters. Let's do that. So we're going to say 300 millimeters. This is millimeters multiplied by the conversion factor, which is 1 meter being equal to 10 to the power 3 millimeters, like that. So the millimeter and the millimeter will cancel out. 300 multiplied by 1 divided by 10 to the power 3. What answer are we going to get? We say 300 divided by 1000. What answer are we going to get?
0.3.
0.3. So this is 0.3 meters. Now let's convert 0.3 meters into mega meters. How are we going to do that? We're going to say 0.3 meters multiplied by the conversion factor. We know to say 1 meter. Or let's do this since the mega is the bigger one. Well, if you want, you can write it in whichever way you want. So we'll just say 1 megameter here over 10 to the power 6 meters. This is going to cancel out that one. 0.3 multiplied by 1 divided by 10 to the power 6. What answer are we going to get? 0.3 divided by 10 to the power 6. This is going to give us equivalently 3.0 times 10 to the power minus 7 megameters. It's a very small number. 3.0 times 10 to the power minus 7 megameters. So we've converted. But if you want, I was just explaining to say you can use this by finding the difference between the two. So we're going to say 10 to the power 6 minus 10 to the power minus 3. This is going to give you approximately how much? I think it will be 10 to the power minus 9 something, or 10 to the power 9, sorry, to give you 10 to the power 9. Then you can use that direct conversion. It should also give you this same exact answer that we found here. Okay, let's come to this one. We solved this one on Tuesday, a question that looked similar to this. So we are converting from square nanometers to square centimeters. It's a very simple question. Sure, I will remember what to do. Remember what to do. Square nanometers to square centimeters. So nanometers, so the nanometer is equal to 10 to the power minus 9 meters. Whilst the centimeter is equal to what? The centimeter is equal to 10 to the power what?
Minus 2. 10 to the power minus 2.
10 to the power minus 2 meters, like this. So we can first convert 250 if you want to take it step by step. 250 square nanometers like that. Let's convert it into meters. So we have 1 meter, which is equal to 10 to the power 9 nanometers, like this. And remember, we said if we are dealing with a square, what are we supposed to do? We're supposed to square our conversion factor like that, which means we are going to have a square there, a square there, a square there. Put this into a square like that, then the nanometer squared is also going to carry a square, which means this square nanometer is going to cancel out with that square nanometer. You can wrap this off since we've distributed it. Then from here, we're going to have 250 multiplied by a meter squared divided by, so say 250 multiplied by the meter squared, this guy, divided by 10 to the power 9 multiplied by 2. So it should be 10 to the power 9 multiplied by 2. This is 18. So divided by 10 to the power 18. What answer are we going to get? What answer are we going to get? Anyone who has found this or who has found the answer for here? Okay, so it's 2.5 times 10 to the power minus 16 square meter. Have we all found this answer?
Yeah.
Yes.
All right, then now let's convert this same value to centimeters or back to square centimeters. So we're going to multiply this by the conversion factor between the meter and the centimeter. And we know to say 1 meter here is equal to what? It's equal to 100 centimeters, which is 10 to the power 2 centimeters. From here, we're just going to square this conversion factor. which is going to give us a square there and a square meter there. Then this 10 to the power 2 is going to also carry a square, or the centimeter is also going to carry a square. So this square meter and that square meter are going to cancel each other. And we are going to remain with it. 2.5 times 10 to the power minus 16 multiplied by 10 to the power 2 multiplied by 2, which will be 10 to the power 4. Okay, so let me just write it on top here. We're going to have 2.5 times 10 to the power minus 16 multiplied by 10 to the power 4 square centimeters, like this. What final answer are we going to get? What final answer are we going to get?
2.5 minus 12.
Okay, 2.5 times 10 to the power minus 12 square centimeters. That means we have converted successfully from 250 square nanometers into square centimeters. The last question is this one, which is saying, write the full names of the following units. Write the full names of the following units. So this one is a very simple question, actually. You can see on the first one, we have a small letter K and a capital letter K. And we know to say a small letter K is used to represent kilo, whilst the capital letter K is used to represent what? We mentioned this last week when talking about physical quantities, but also units of measurements. Those tables, they're the ones that contain the symbols for each and every unit of measurement, but also physical quantity. What does the small letter K and the capital letter K mean? Okay, so the small letter K is for kilo, whilst the capital letter K, as you remember, it's for Kelvin. The unit of measure, the SI unit of measurement for temperature. So this is kilo Kelvin. Kilo Kelvin. That is 1. What about 2? A small letter m and a capital letter T. On that table that I displayed to you on derived units of measurement, there was a capital letter T. What was it representing?
Tetra.
Tetra. Okay. Anyone else?
Tera.
Tera. Okay. Anyone else?
Milli.
Sorry?
Milli.
I can't really get what you are saying. I don't know why.
Milli.
Okay. So she mentioned for the small letter m. It's for milli. Now I'm asking about the capital letter T. What is it? What unit of measurement?
Tega.
I'm getting a lot of answers. There's tera, tetra. I can't really get what you people are saying. I can't really get what you people are saying.
Temperature. It's
Tem-
Tera.
temperature. Tera is a prefix. Tera is a prefix, so it can't be here. Tera is a prefix. Remember that table for metric prefixes? There's tera, there's giga,
Tega.
tega. Hmm.
Okay, I think the T has to like present maybe temperature.
Okay, are you sure?
No, I'm not.
What is this word here?
Tesla.
Tesla. Tesla. Now, what do we use Tesla for? What do we measure Tesla for? That will be the next question, because 2 is for midi Tesla. So what do we use this for? Which physical quantity do we measure using this guy?
Magnetic field.
Okay. Okay. People who study. I don't know the third one. What unit is it?
There
Microjoule.
is a micro
Okay, so
joule.
there's a micro,
Microjoule.
there's a micro, but there's also a capital letter J for joule. Like that. So this is what is represented by that. Then we have the last one, capital G and capital W.
Gigawatt.
Okay, so capital G is for giga, whilst the capital W is for the watt. So that is basically a gigawatt. That means you are done with the whole tutorial sheet. Was there anything difficult here? Was there anything difficult in this particular tutorial sheet? You've seen, got to say everything was direct from what you learn. They don't bring things that are out of context. You just have to apply a bit of intelligence since you're a student. Of course, you guys are going to become medical doctors, medical practitioners. So it's just a bit of reasoning, then it should be okay. So is there anyone who has a question from this tutorial sheet? Anyone with a question?
No question.
Okay, so thank you very much. If there's no question, I really, really appreciate your coming. Let's be coming in numbers just like this. We should meet again tomorrow because tomorrow we are having biology. Our first class in biology will be tomorrow, a Saturday. So let's also come in very good numbers like this.